So today we are going to focus on the topic of electromagnetic spectrum. Okay. Um, so in astronomy, when we talk about electromagnetic radiation, sometimes we refer to as light. But when we talk about light, we not only talking about visible light, we're also talking about other kinds of light inside the electromagnetic spectrum here. Okay, so as you can see, the visible spectrum is only a very small part of the total electromagnetic spectrum here, as you can see, right? Okay, so this is what we call uh, rainbow color inside the visible range of the electromagnetic spectrum. So again, when we talk about electromagnetic radiation or when we talk about light, we are referring to the whole electromagnetic spectrum going from radio wave all the way to gamma ray. So what is the difference between different types of electromagnetic radiation here? Okay. In fact, I'm going to post the second writing assignment very soon. That second writing assignment is going to ask you to study in more details about electromagnetic radiation as well as some particular type of electromagnetic radiation you really like to investigate. Okay, so here I just want to give you a guideline about different types of electromagnetic radiation inside the spectrum. Okay, so different colors of light actually, or different types of electromagnetic radiation here, they have different frequency, or we can say different wavelength. Okay, so this is actually a very important concept. I hope that everybody can remember after today's lesson. Okay, when we talk about red light, you think about longer wavelength in the visible spectrum. When we talk about blue light, we think about higher frequency, because frequency and wavelength actually they always go in opposite ways. So when some light has longer wavelength, that means they have lower frequency, and vice versa. So if you take a look at this spectrum here, okay, radio wave, as you can see, from here to here the frequency is getting bigger, from here to here the wavelength is getting bigger. So radio wave has the longest wavelength, okay, and then lowest the frequency here. But on the other hand, the gamma ray has the highest frequency, but the smallest, the shortest wavelength. So when we talk about frequency, we use higher frequency, lower frequency to talk about it. When we talk about wavelength, we use shorter wavelength or longer wavelength to describe it. Okay, and then the next one is infrared. Okay, and then we go to visible light. After that is ultraviolet light, X-rays, and gamma rays. Okay, so you can find all these the applications of different types of electromagnetic radiation in our actual daily life. Okay, so for instance, for radio waves, if you turn on radio, okay, so how do you receive the information? So basically, the radio station is going to play the music, and then they're going to actually send information through some kind of radio wave based on their frequency. Okay, so because different radio wave, different radio station, they have different frequency. So that's if you say 106.9, so that is referring to the frequency of the radio wave. And then whatever the music they're playing is going to be sent through the radio wave, and then when you turn on the radio on your side, the radio is going to separate the radio wave and the music. So then eventually your receiver it's going to be able to play the music, whatever the radio station's playing. So that's one example of the radio wave here. Infrared is used a lot in military applications because it's like heat related electromagnetic radiation. Next class, I'm going to, actually ask you guys to watch a video which is related to infrared light. For visible light here, okay, visible light actually is the kind of electromagnetic radiation we are very familiar with. As you can see here, the visible light goes from, the wavelength of the visible light goes from 400 to 700 nanometers. So nanometers is, 1 nanometer actually is 10 to the negative 9 meters. Okay, it's a very tiny unit. Okay, and I wanted to pay attention to have a concept of what is the wavelength for visible light. It runs from 400 nanometers to 700 nanometers. So our eyes actually are most sensitive to yellow greenish light, which is about 550 nanometers range. Okay. Then if we continue to move towards the higher frequency range, we are meeting ultraviolet, which is UV light. Okay, when in the summertime you need to put the sunblocks on to protect yourself from getting some UV light. Okay, and then you go to X-rays. If you go to, like, say, dental office, so they can take some X-rays for your teeth. And gamma rays can be used for some kind of, knives for operations, surgicals, for surgeries. So again, I said, I am going to give you a second writing assignment, so you guys can pick one of your favorite electromagnetic radiation, and you can do a little bit more research on that particular type you chose. Okay, next slide here, okay, again shows you, okay, the full electromagnetic spectrum here. Okay, and again here you can see for radio wave, actually radio wave could have a wavelength as big as a mountain. Okay, and then for the gamma rays, they are going to have a wavelength which is about atomic atomic nucleus size. Okay, so as we move from radio wave to gamma rays, and you can see the wavelength is getting smaller, but the frequency is getting higher. Okay, so let me go back to the previous slide. Again, here I want you to pay a little bit attention on the visible light range here. So you can see that red light actually is on the longer wavelength side of the visible light, but however, blue light and violet light actually, they are on the higher frequency range of the visible light spectrum. So I do hope that you guys please get yourself familiar with this diagram here, especially how the frequency is going to change, how the wavelength is going to change, and then also that red light has invisible light range, red light has longer wavelength, but blue violet light has higher frequency, shorter wavelength.